Okay, today I'm excited to bring you this video on estimation because I believe estimation is one of the most important concepts in math. The reason I believe this is because I believe estimation is the key to fluency. Once a student can estimate, it means they understand what the problem is asking and they have a reasonable idea of the answer. And it means that when they go through whatever processes they've learned at the end, they have some idea of whether they have done it well or not, and they have the opportunity to self-correct. Self-correction is really the key to fluency in reading. The ability to know when you have read something wrong, you go back and you fix it for yourself. That's what allows one to become a fluent reader. I believe the same thing is true in math, and so once self-correction is used, students can learn math much more effectively and efficiently when they can find their own mistakes, know that they've made a mistake, and know to think back through it again. So with that in mind, I'm going to try to show you how I try to help students work through estimation. First of all, there's a big problem that I see with students coming in is those that have spent time on estimation have calculated first and taken the time to do calculations and rounded after a calculation, which is not quick, not efficient, and not useful as estimation. It will not be the kind of thing that they will do by habit and allow them to see if they've made mistakes or not. So we need to take that calculation and rounding, and estimation requires you to flip them. So you should be rounding first before you calculate so that it is the type of thing you can do within just a couple seconds. So you're going to round first, then you're going to do a calculation, and you may at that point decide to do a little bit of an adjustment to your answer. Now, what's really exciting about this is it is hard to test your estimation skills, so I have found a game that I'm really excited to show you estimation in action. And so this game is at, so it's actually at the site at the bottom here, mathisfun.com, and I just Googled it to find it. And so I'm going to do this a little bit and see if I can't show you how this works in action. So I'm going to do estimation with large numbers, addition, to start off with. Okay, and I'm going to talk you through what I would do. So here I'm looking at the front numbers. That's where the most things happen, and so in my head I'm thinking 2 and 2 makes 4, so we're talking 400, and then the other stuff I'm going to adjust up 1 to see that it came up to 500. This one I see 2 and 1 is 3, the other stuff is getting close up to 400. Okay, 1 and 1 is 2, and we're about halfway up as I look beyond it. I notice I'm trying to go pretty quick, and I'm not really worried about the last parts of it. 4 and 4 is 8. That's actually really high, so I'm thinking it's close to 9. Okay. Those are 2 that are almost 5 each, so we're pretty close to 1,000. All right. 2 and 3 is 5. Those are actually going over the next one, so I'm somewhere over 600. 4 and 4 is 8, and the little pieces get my over 900. 4 and 2 is 6. That one's actually really almost 5, so we're talking 7.5. So 4 and 4 is 8. Okay, so you can see this game. There was a timer clicking down there, but what you see is that I'm front end rounding. I'm looking at the front end, and I actually did not follow rounding rules. I a lot of times just looked at the front digit instead of wasting my time even thinking about the rounding rule, and I considered that part of the adjustment. I'll go through this one more time with the addition, and then I'll probably make a new video for subtraction and multiplication. So 2 and 2 is 4 and halfway up with the rest of it. 3 and 4 is 7 and almost close to the 8. 2 and 1 is 300. The other pieces is actually going over the 400 mark. 4 and 1 is 5, getting over the 6 with the rounding. 1, 3, getting over the 4. 4 and 4 is 8.5-ish. 4 and 3 is 7 and halfway up to the 8. 3 and 2 is 5 and a little bit. That one, since it ends in 0, so you probably don't have to work. 7 and 3, or 4 and 3 is 7 and a little bit over the 8. 5 and close to 6. 5 and over the 6. 7 and over the 8. 2 and 2 is 4, well beyond the 5. Okay, and so that was another practice of estimation with addition. Let me go ahead and do a subtraction to show you how we follow the same sense of habit. So now I'm subtracting the front end numbers, and I'm seeing the other ones balance, so they almost cancel each other out. So I'm subtracting 1 minus 100. All right, so that's canceling out pretty much all the way down to nothing. These are all pretty low. So 200 minus 200, sticking with the low numbers. Maybe this isn't great for this one. Getting close to 100. 3 minus 3. 4 minus, they're only 50 apart-ish. So I'm looking at the front end and seeing what the difference is there, and then I'm looking past to the second numbers and seeing what the difference is there. 200 minus 200 is nothing, so I'm looking past it to the 45. I got 200 almost, and the other numbers pretty much balance. So looking at the front numbers, there's a good one, 200, and then the 40 would have been what was left over. Let's do one with multiplication and see how this front end rounding might help out. So I'll do multiplying with tens. This is actually a pretty good practice for estimation, the multiplication one. For this one, I see 20 times 10 would be 200. Actually, I probably want to look at this as 20 times 20, so I'm seeing 400-ish. Okay. 40 times 40 would give me 16. With the two zeros would be 1600, and then some. So I'm going to move up quite a bit. Okay, and I didn't move up enough. 30 times 20 would be 60, and plus quite a bit more. Actually, when I teach multiplication estimation, I like to teach to round one of them up and one of them down, so I might think of this as 20 times 50. We'll see how that helps me out. All right, 10 times 20 would be 200 and some. All right, I'm going to go 40 times 30, which would be 1200-ish. 600-ish here, because right in the middle of 400. I'm going to go 20 times 40, which would be 800. All right, I'll go 30 times 10 for this one, so 300, and see how that helps me out. So there's some estimation practice. Notice that I'm paying attention to the left side of numbers to estimate, and I think this game, you could really work on doing it quickly in your head, and you can probably beat some of the scores that you saw me do here. So good luck with that, and keep working. Thanks.